Well, hi, this is Jay Arthur. Welcome to Data Mining, Practice and Application. So it's pretty clear that if you don't practice what you've learned and then apply it to your own situation, you just won't get it, right? So what we want to do here is start to practice. And I can guarantee you when I first started, I was not very good at this. But that's why that I built ChartSmartXL, is to simplify the whole process. If you go out into ChartSmartXL and go to ChartSmartXL Help, you can see that we have a thing that will open test data. And in here there's a file called PivotTable. And so just go ahead and open that up. I've already got that open, so we'll use it. The thing to do in data mining is you just want to click on the date, hold down the control key and click on something else you want to know something about, like defects, and then click on the data mining wizard. The data mining wizard will go out and create a pivot table, a performance chart, and Pareto charts for all the data within there. And so down here at the bottom you can see we have a performance chart of defects by date. So we know we have a stable process, there's no red points. If we look at our defect by type of defect, we have folded flaps, bent and damaged, carton will not open. And then on another way of looking at it, we have line 3 is over half of our total defects. So we could go at this either way. We could look at it from the perspective of type of defect, or we could look at it by what's our worst line, and maybe we ought to fix that worst line first. All right, and then if you feel ambitious, get into your pivot table. If you double click on this cell, line 3, which is our biggest bar, that'll bring up all the data about that. And then if you click on just the defects for line 3, just click on that heading and choose Pareto chart. It'll draw a chart of defects in line 3. So now we've drilled down from line. Now we know that in line 3, folded flaps are 39.5% of our total. All right, so that's our improvement project. So in this situation, we see that folded flaps are 39.5% of our total. So we can go out and start to do root cause analysis on that. Now there's some other data files in here as well. So we have by date, we have lost time, causes. So I might want to know by date, I want to know lost time. Click on Data Mining Wizard. Data Mining Wizard will again summarize this using a pivot table, create a performance chart, and Pareto charts showing us what's going on there. So we have lost time by date, lost time by cause. Generator failure here is clearly the leader with 2/3 of the total. And that's about it. All right, so we know what our pivot table is here. So you can keep going down through here. So here's hospital denied claims. If you click on there, click on 2 columns, click on Data Mining Wizard, it'll go out and start to create a performance chart of denied claims by day. And then it'll also create Pareto charts for each one of the different columns that are out there. And what we want to do is, once we've created all the Pareto charts, we want to go look through there and say which one is the most interesting point of entry. Where do I want to start? What am I curious about in here? All right, and you can see that the Data Mining Wizard is just going to keep banging away through everything that's out there until it gets through all of the information that's in that spreadsheet of defects. So we scroll over here a ways. Here's our performance chart. You'll notice it has a slightly different colored tab. So we can count on $1,900 a day in denied charges. Then we have it by entity, which is type of hospital, by region, but the bigger hospitals in the south, so that didn't really tell us anything. I don't remember what OL stands for, but that's not the path we went down. There was another type of thing called COS, but this is a pretty flat Pareto, so there's really not much going on there. Denied charges by function code. Wow, this looks interesting, right? So we have X, which actually stood for transfers. 51% of the total. F was 83% of the total, and whatever this code was 95%. So if I fix those three things, I could fix most of my denied charges. That's a pretty interesting way to look at the thing. There was a type of insurer. There was another type of behavior here. I can't remember what O stood for, whether it was outpatient or whatever. 47%, on and on and on and on. All right, so by memo type, by payer issues, so on. And then by delay, that really has nothing to do with it. All right, so that was our analysis of this data for healthcare. And we have things about ICU medication, patient falls, all of these things, so we might want to know by date, by unit, what type of problems occurred. The data mining wizard will go out and summarize patient fall data and create, again, a performance chart, which looks wildly out of control, and also create Pareto charts for each type of column in there. So it might be by location, it might be by type of fall, it might be whatever. So again, we can let it build all of these, and then we're going to go back through and look for which one of these is the most interesting Pareto chart to investigate. All right, so that's practice and application using the data mining wizard. All right, so we can go back in here. This looks a little odd, of course. By location, nothing going on there, no colored bars. Shift 1, most falls happen on shift 1. That's days. Wait, what's that all about? Well, they might be sleeping the rest of the time. It's mainly at the patient bedside. So, well, that tells us something. What intervention did we use? Non-skid socks. You can see non-skid socks are in here a couple of different ways, so that means we didn't spell it the same. It was accidental as opposed to planned. We planned to fall. It was in a dry area, not a wet area. Well, that's interesting. They might be on blood pressure medication, so that was a big trigger. And locations, people that are actually on alert. They're looking for patient falls. Or the patient's behavior. And where did they fall? Mainly on their backside. Type of injury, on and on. Okay, so that's our structure here. And maybe the most interesting one in here might be the location of the fall, bedside. So what are we going to do to fix bedside falls, and are the non-skid socks working, and so on. So that's the essence of this whole process. Go grab some data, click on a date, click on a thing you want to know something about, and then practice. And then what I'd like you to do is go find some data that looks like this in your organization and do the same thing. And see if there's some sort of problem in there that you can fix easily. So that's our practice and application in data mining.